Okay, everybody. Today we're talking about different parts of algebraic expressions. Two learning objectives for the day. The first one, I can identify different parts of algebraic expressions. And second one, I can write phrases as algebraic expressions. Starting off, the different pieces of algebraic expressions. We have variable, term, like terms, constant, coefficient. So 5 different vocab words. Let's break them down. Variables are just letters that represent unknown numbers. Most likely they're represented by X. They could be represented by Y, Z, A, M, D, whatever. Any letter is a variable. Terms are numbers, variables, or a product of a number and a variable. Example, 3x plus y. That has two terms. The 3x is one term and the y is another term. An easy way to find terms is by looking at what's separated by pluses or minuses within expressions. Like terms are terms that have the same variables or are all constants. So here's an example. You have 3x plus 2x. Since that has the same variable in both terms, those are like terms. Constant terms are terms that only contain numbers. So in this expression, 4d minus 5, that minus 5 is a constant. It's only a number. Coefficient, the number multiplied by a variable. In this expression, 5t, that means 5 times t, that 5 is our coefficient. I have a lot of different words to go over from this word bank, and we're going to split them up into the 4 different operations and then what I call taffy words. This is going to help us take word phrases and break them into algebraic expressions. So let's start from the top left. It says the quotient of. Quotient is our division. So we could put it in for division. The sum of is addition. Product, multiplication. The difference of is subtraction. Plus addition. Is something that's not in the little table below. Is means equals. So we're going to pay very close attention to is when we're looking at equations. Decreased by means subtraction. Increased by, the opposite, means addition. Less is subtraction. Divided by, well, that's kind of an obvious one. Division. Minus, subtraction. Into also means division. Notice that one's red. Pay close attention to that one. Times, multiplication. Less than, close to the less, but you have the than afterwards, and notice that one's is red as well. More than, that than is also red, but more means addition. A number, not any one of these operations, not a taffy word. A number is what they use to represent that variable. So most of the time it's going to be represented by that x, but whenever they're talking about a number, it's that variable. Subtracted from. Well, subtracted means subtraction, but notice red for the from. And then I have one more on here that's not in the word bank, but the opposite of subtracted from, added to. So all of those words we're going to be dealing with our different expressions. But I want you to notice some of those words were red as we filled them in. Those red words are the taffy words. And these are special words that mean we have to switch the order in our algebraic expression. And you'll see examples of that throughout this lesson. But whenever you see into, from, than, added to, you take the order of the expression and you flip them around your operation. So T-A-F-I, taffy words, that's than, added to, from, and into, T-A-F-I. Flip the order around. Let's get into it. Here's our first example. 2z squared plus y plus 3. Whenever I'm looking at this and I'm trying to identify the different pieces, the first thing I like to do is look for the terms. Terms I could tell because they're separated by either plus signs or minus signs. So I have 2z squared before that first plus sign. Then after the plus, I have a y. Then after another plus, I have a 3. And that's all the pieces. So I have 3 total terms. 1, 2, 3. Now, looking at those terms, which one or ones are the constant terms? Well, remember, constant just means the number. So which one of those only has the number? It's the last one. It's that number 3, our constant term. Variables, another nice one I like to look for before I look at coefficients. So what are the letters in this problem? That's z and y. Now that we know what the variables are, we can tell what the coefficients are. I have z squared. What am I multiplying this z by? I'm multiplying it by 2. I have y all by itself. That's not a 0 coefficient. It has an invisible 1 coefficient. So my coefficients for this problem are 2 and 1. Going on to the next example, I have x divided by 5 plus 13. Keep in mind, the multiplication and division doesn't separate terms, only the pluses and minuses. So that plus in the middle means I have one term before it, one term after it. So I have 2 terms. Of those 2 terms, do I have any constant terms? Do I have any terms that are just numbers? The answer is yes, I do. It's 13. So my constant term is 13. Again, let's go to the variable. Let's look for the letters. What's my only letter in this problem? X. And the last thing, we're looking at coefficient. This is where it's a little tricky because it's not being multiplied this time. It's being divided. So is my coefficient 5? No. I think of that x divided by 5 as 1/5 times x. They are the same thing. They equal each other. X over 5 equals 1/5 times x. So my coefficient is that 1/5. Taking our expressions, breaking them down into their pieces. There's 2 examples. Now I want to get into the other objective. I want to look at expressions and write them as algebraic expressions. So here's the first one. The difference of 24 and a number. Well, difference I know from our word bank, that means subtraction. I have 24 and a number. Do I see any taffy words here? No, I don't. So I don't have to switch the order. I could keep the 24 first. A number just means variable. I could keep that second. No taffy words, no flipping. Take a look at this other problem here. We have $9 more than Sally. $9 more than. More means plus. Any taffy words this time? Yes, the T in taffy, the than. That means I have to switch my order. So Sally, which was second, now goes first. And I'm going to use S for Sally. 9, which was first, goes second. And that's because of that taffy word. There's some adding and subtracting ones. Let's look at some multiplying and dividing ones. Here's the product of 5 and a number. Product means multiply. So let's take our number and our, it looks like a variable. It just says a number. So let's take a variable. I'm going to use x again, and let's multiply them together. Now here's one nice thing to remember. When we're in Algebra 1, we don't need a multiplication symbol in between them. We could just take the number, take the variable, put them together. It means multiplication. Remember, lazy mathematician, looking for shortcuts. That's a shortcut we get to use. We have to write the other operations. We don't have to write down multiplication as long as it's between a number and a variable. Let's look at another one. We have x into 45. If we go to our word bank, into means division. But into is also a taffy word. It's the I in taffy. So that means we're going to take those pieces of the phrase and twist them around. So I have 45, which was second, is now first, and I have x, which was first, That's now last. So I have 45 divided by x. Let's do a couple more. These next two are going to be a little trickier. This time we're looking at more of a compound phrase where there's multiple operations in the phrase. So, for example, this one says 5 less than 3 times the number of points. Well, let's break down the first part. It says less than. Less means that subtraction. Than is that taffy word. So we want to take that 5, which is first, and put it second. Now we can look at the other piece. It says 3 times the number of points. We don't know what the number of points are. So we're going to use a variable, and we know what times means. It means multiply. So I could have 3 times my variable. Emphasizing again that taffy word than. We don't do 5 subtract 3x. We do 3x subtract 5 because than changes the order. Last one. This time it says a number squared plus 10 as an algebraic expression. When we're looking at squared, cubed, to the 4th power, to the 5th power, those are our exponent phrases. Squared means I have an exponent of 2. So this number squared is unknown. We don't know what the number is, so I'm going to use x squared. Then it says plus 10. Is plus 10 taffy word? No. So I could just keep it in the same order, plus 10. Emphasizing this one, squared means to the 2nd power. Cubed means to the 3rd power. And then they don't really have fancy names after that. It's just to the power of, or to the blank power. So to the 4th power, to the 5th power, to the 6th power, so on, so on, so on. So there's our lesson, guys. We took different algebraic expressions and broke them down into their pieces, terms, coefficients, variables, and constants. Then we took different phrases and broke them down into algebraic expressions. Thanks so much.